Welcome to the Compressed Gas Cylinder Training Module. This module will cover the following topics: basic description of compressed gas cylinders, how compressed gas cylinders are used, potential hazards of compressed gas cylinders, and best practices for storage, transport, and use of compressed gas cylinders. Compressed gas cylinders are portable tanks used to store, transport, and dispense gases for use in a broad range of industrial, research, and medical applications. The purpose of a high-pressure gas cylinder is to serve as a reliable source of a specific type of gas for a specialized function. To accomplish this, a large volume of gas is compressed into the relatively small volume of the cylinder. The result is a versatile, high-pressure cylinder that can be easily delivered wherever it's needed. These metal cylinders are designed to be strong and durable, but can create potential health and safety hazards if not properly handled. High-pressure compressed gas cylinders range in size from 2 to 10 inches in diameter and from 2 to 5 feet in height, and have thick metal walls. Here are the specifications for a common industrial high-pressure cylinder. Height, 5 feet. Diameter, 9 inches. Wall thickness, 1/2 inch steel. Weight, 140 pounds. Internal capacity, 1.8 cubic feet, about 14 gallons. Design pressure, 2,400 pounds per square inch. A main fill and shutoff valve is secured into the single opening at the top of the cylinder. When the cylinder is put into use, a pressure regulator is attached to reduce and control the pressure of gas flowing from the cylinder. When the cylinder is not in use, the regulator is typically removed, and a protective cap can be screwed over the main valve for safe storage. Some cylinders have a built-in protective ring in place of the cap. Under certain conditions, these cylinders can present physical and/or chemical hazards to those who transport, handle, or use them. Physical hazards occur as a result of improper handling of the cylinder itself. Heavy, awkward cylinders can crush body parts or inflict lethal injuries if they fall or unexpectedly release high-pressure gas. Potential chemical hazards are posed by exposure to the contents of a cylinder. Chemical exposure from the small leaks resulting from improper fittings or a large gas release caused by equipment damage can have immediate and acute or lasting chronic health effects. Because the gas-containing steel cylinders are heavy, tall, and narrow, they tend to have a high center of gravity. This means that they can fall over easily if unsecured during transport or use. The impact from a falling 140-pound mass of steel can crush bones and break equipment. The force of gas rapidly exiting the tank due to an equipment malfunction poses a danger to eardrums and eyes. If the main cylinder valve breaks off, the cylinder can actually become a missile. If the cylinder ruptures, the effect on its surroundings will be bomb-like. When a typical cylinder is filled to its design pressure of 2,400 psi, it will contain almost 300 cubic feet of atmospheric pressure gas, or about 160 times the internal volume of the cylinder. This compression of gas represents a tremendous amount of stored energy. If the outlet valve is broken off, the sudden release of compressed gas can turn the cylinder into a missile with energy to shoot through a cinder block wall. In one reported incident, a damaged cylinder penetrated 2 sheet metal walls before becoming airborne and exiting through the roof. The tank reached an altitude of 140 feet before falling back through the building's roof a second time. When a steel cylinder becomes a projectile, it can move with great force, at high speeds, and in unpredictable directions, with the potential to cause serious or fatal injuries. The potential chemical hazards related to gas cylinders are associated with the nature of their contents. Common cylinder contents can be classified as follows: inert, flammable, toxic, or both flammable and toxic. Inert gases such as nitrogen and helium are neither flammable nor toxic. However, if a large amount of an inert gas is accidentally released into a poorly ventilated room or confined space, the otherwise harmless gas will displace normal oxygen-containing air. This will result in a dangerous low-oxygen atmosphere, which may lead to unconsciousness and even death. If a leaking or broken cylinder contains a flammable gas, such as hydrogen, methane, or propane, normal air will also be displaced, but that will not be your greatest concern. Clouds of flammable gases ignite easily and burn explosively. Leaking hose connections, faulty valves, and ruptured cylinders can release flammable gases that could accumulate in confined spaces. Electrical outlets, switches, open flames, and other ignition sources can easily ignite these clouds. Oxygen is a common compressed gas which is not directly flammable or toxic. Nonetheless, an excess of oxygen in an enclosed area still presents danger. Because oxygen is such a powerful oxidizer, it enhances any combustible material's ability to burn. Fires in an oxygen-rich atmosphere will start more easily and burn more quickly and intensely than in normal air. For this reason, in a pure oxygen system, even grease and oil in fittings and regulators must be avoided in order to prevent their combustion. High-pressure gas cylinders which contain an inherently toxic gas present the greatest danger. Accidental exposure to a released toxic gas presents an immediate hazard. Gases such as ammonia or chlorine will quickly attack and burn the eyes and sensitive nose and lung tissues. To prevent exposure, extra care should be taken to be sure that all toxic gas hose connections and valves are sealed and operating properly. Unexpectedly released toxic gases can disperse quickly, leaving little time to react. Even at low concentrations, these gases can overcome personnel. Keep in mind that some common industrial gases, such as carbon monoxide, are both flammable and toxic. The inherent risks associated with handling, storing, transporting, and using compressed gas cylinders can be mitigated by following some established best practices. Cylinders which are not in use should never be stored in active work areas. A dedicated storage area, appropriate for the types of gases stored, should be used. For safe storage, compressed gas cylinders should be placed in a well-ventilated, non-corrosive, dry environment, protected from excessive heat, separated by hazard classification, secured in an upright position with a chain or strap above the midpoint of the cylinder, prepared for storage by placing the protective valve cap in place, clearly labeled. Empty cylinders should be clearly marked and stored separately. The risk of an accident is the highest when cylinders are being transported and set up. Safely moving compressed gas cylinders requires specialized equipment and extra caution. Follow these best practices to avoid problems that could occur during transport. Wear safety shoes, gloves, and any other appropriate personal protective equipment. Move cylinder secured to a hand cart specifically designed to safely transport cylinders. Always keep the protective valve cap in place during transport. The cylinder may be slightly tipped and rolled on its base for only very short distances. Do not drag a cylinder or roll it on its side. Never lift or move a cylinder by the valve or cap. When installing high-pressure gas cylinders, follow these best practices. Wear safety glasses, goggles, or a face shield when setting up a cylinder. Position the cylinder away from pedestrian and equipment traffic. Ensure that any cylinder in use is securely anchored to something solid using a strap or chain. Never rely on connection piping to hold a cylinder in place. Carefully remove the protective valve cap. Do not use excessive force or prying tools, This can lead to valve damage. If the cap is stuck or damaged, return the cylinder to the supplier. Use only compatible connections, hoses, and equipment. In order to prevent mixing of gas types, the thread type and size on the main cylinder valve should match those of the regulator. A regulator should connect easily to a cylinder valve. Never force a regulator connection or put gas to a regulator which is not firmly connected to the cylinder. Ensure that the pressure regulator is closed or relieved before attaching it to a tank. Easy access to the main cylinder valve should always be maintained. Do not allow piping, clothing, or anything else to obstruct access to the valve in case of a need to quickly shut it off. Follow these best practices when using a high-pressure gas cylinder. Be aware of the properties and hazards related to a cylinder's contents. Read the content label. Never make assumptions about a cylinder's contents based solely on the color of the tank. Open and close valves using hand pressure only. Never use an extender or excessive force. Open main cylinder valves slowly when initially pressurizing regulators. Do not stand in front of the regulator as it pressurizes. Only open the main valve enough to achieve sufficient gas flow to allow for a quick shutoff in the event of an emergency. Once gas is flowing properly, check the fittings and all associated tubing for leaks. Use a soap solution or electronic leak detector. Never use an open flame to look for leaks. Close the main cylinder valve when the cylinder is not in use. When a cylinder is empty, clearly mark the side of the tank, remove it from operation, and prepare it for storage. Leave a slight positive pressure in the tank and close the main valve. This will prevent the tank from becoming contaminated during storage. Replace the protective valve cover and return it to a storage area. Keep empty tanks separate from full tanks. Since gas welding and cutting operations represent a common use of compressed gas cylinders, let's review some fundamental best practices for the safe use of flammable gases. Work in a well-ventilated area to avoid exposure to harmful chemicals and fumes. Ensure that mobile welding carts are stable and appropriately sized for the cylinders you're using. Keep the gas cylinder secured and upright at all times. Placing an acetylene tank on its side can disrupt gas flow and potentially release flammable liquid acetone. Inspect all equipment and replace worn or damaged hoses, valves, or components. Secure all hose connections and test for leaks periodically. Wear PPE appropriate for the job. Be sure that both gas lines have a flow check valve at the torch and a flashback arrestor at the regulator. When the job is complete, securely close all valves and purge the lines to release pressure in the hoses and torch. High-pressure compressed gas cylinders provide a practical method for supplying a variety of gases to end users. As we've discussed, the high pressures within the cylinders and the nature of their contents present serious safety concerns to those who work the cylinders. Knowing the nature of the hazards presented by high-pressure gas cylinders and how to behave in order to minimize those hazards will ensure your safety and help reduce accidents related to compressed gas transport and storage.